Hello students and welcome to Smart Kids tutorials. In this video, we will be solving a few MCQs on circles, and this may even come for 2 marks. So just some request of my students to do some MCQs and mark circles in the last moment. I'm just doing a few of them, may be useful to you. So let's begin. I've uh, um, got 10 of them to do. So let's see which are they. Okay. And I have got a paper with me myself, but for a good copy of this, I will share it on the WhatsApp channel, so you may go through that. Okay. Let's begin. First one. The first one says if radii of two concentric circles are 4 centimeters and 5 centimeters, then the length of each chord of one circle which is tangent to the other circle is one of the. So first, let me just draw this picture. I mean the diagram. So just do the rough diagram. So it says there are two concentric circles. So we take one concentric circle, and there's another concentric circle. It says there are two radii, 4 centimeters and 5 centimeters. And length of each chord of one circle is tangent to the other circle. So if we take this as the chord of the big circle, it becomes a tangent to the smaller circle. Okay. If radius, where this is the center, radius of the smaller circle will be this, and radius of the big circle we can draw this way so that we get a triangle. Makes it easier for it. Okay. We are told that the radius of the bigger circle is 5 centimeters. One of the smaller one is 4 centimeters. And we are asked to find out the length of this chord. Okay. So the first thing that we need to do, the diagrams, of course, the main thing. But now that we know that we got a circle over here, and this is perpendicular because this is the tangent. Okay. The point at which the line touches the circle over here becomes perpendicular. So this is perpendicular, and so this we can easily find out using Pythagoras theorem. And if we find this because this is equal to this because perpendicular from the center bisects the chord. So let's begin. So quickly, as I said, this is for 1 mark. Um, even the working can come for 2 marks. So it will be useful to me. So first, I say I'll take this over here. Since the diagram is not given, I can easily take this as O. I can take this chord as AB, and I can take this maybe as C. Okay, I can say since OC is perpendicular to AB, and why is OC perpendicular to AB? Because AB is tangent to circle. Now, this is OC is perpendicular to AB. That means we can use the Pythagoras theorem. So we can say by Pythagoras theorem. For 1 mark, you don't need to show all this working. Okay, especially in MCQ. But if there's 1 mark question, because after 16, 17, 18, 19, 20, 1 mark where there are no multiple choice questions, you have to solve. There you can answer both. Have a look at how this is done. So we give here the OA square, which is hypotenuse. OA is hypotenuse. OA square is equal to OC square plus AC square. Now we need AC square. So I'm going to take AC square is equal to OA square minus OC square, or AC is equal to square root of OA square minus OC square. What is OA? OA we are given as 5. So 5 square is 25. And OC is given to us as 4. So 4 square is 16. We get square root of 9. And square root of 9 is 3 centimeter. So this is 3 centimeter. So this is 3 centimeter. This is 3 centimeter. Total will be 6 centimeter. So if you want, you can write. So AC is equal to BC, which is equal to 3 centimeters. Why? Perpendicular from center bisects chord. Okay, this is what you should know. And therefore you can say AB is equal to AC plus BC, which is equal to 3 plus 3 equal to 6 centimeters. Okay. So if we have a look at our, you see, B is the correct answer. Let's move to the next question. It says in this figure, if angle AOB is equal to 125 degrees, then angle COD is equal to what? If you have a look at this, it, you will not be able to find anything. Then the theorem, it says, this is what the theorem says. So I'll write it down over here. Okay. Okay. It says, so opposite sides of a quadrilateral, okay, opposite sides of a quadrilateral, circumscribing a circle subtends supplementary. Supplementary means 180 degree. Complementary means 90 degree. Supplementary angles at the center of the circle. Okay, center of the circle. We can say hence angle COD will be equal to 180 degrees minus 125 degrees, which is equal to 55 degrees. And the correct answer is D. Okay, see what it's saying. Here 125 degrees over here. Okay, we need to find angle COD. But don't mistake this for vertically opposite angle. This is not vertically opposite angle. Okay, over here. So when I show you the actual figure, it will look a little bit different than what is shown over here. So what it says is, if there is a quadrilateral which is circumcising a circle, then the sides opposite, okay, the sum of these two at the center will be 180 degrees. That means 125 plus this angle will be 180 degrees. And that is why I've said 180 degrees minus 125 degrees gives us this. Because this plus this should become 180 degrees. And that is why 55 degrees is the correct answer. Okay. Third question, in the figure, AB is a chord. AB is a chord, okay, this one of the circle, and EOC is the diameter. EOC is the diameter such that angle ACB is 50 degrees. If AT is the tangent to the circle at the point A, then BAT is equal to 1 of these. Okay. So here we can see this is the diameter, and we know that angle formed in a semicircle, okay, becomes 90 degrees. So this has to be 90 degrees. We know this. We can easily find out. So 90 plus 50, 140, 140 plus 40 gives us 180. Okay, so this is the sum of angle of triangle. This is 40 degrees, and we know this full thing is 90 degrees. We can find out the remaining. So that's what we are going to do. So we say angle ABC is equal to 90 degrees. Okay. And we say this is the angle in a semicircle. Then we say in triangle ABC, angle A plus angle B plus angle C equal to 180 degrees, which is sum of all angles of triangle. Then angle A we can leave like that. B is 90 degrees, which we have proven over here, plus C is given to us as 50 degrees, 180 degrees. Therefore, angle A will be 90 plus 50 is 140. If we take it on the other side, it becomes negative. 180 minus 140 will give us 40 degrees. Okay. Now, angle CAT is equal to 90 degrees. Okay, AT is tangent to circle. Okay, now if you want to see where we have reached, we have got this as 90 degrees. We have found this as 40 degrees. And now we are saying that angle CAT, this full angle, is 90 degrees. Why? Because AT is tangent to the circle. This full angle minus this angle will give us BAT. That's what we are going to write. Angle CAB plus angle BAT equal to 90 degrees, equal to angle CAT. Okay, but CAT is equal to 90 degrees. Angle CAB we have been given 40 degrees. And angle BAT is what we need to find out. So that means therefore angle BAT is equal to 90 minus 40 is 50 degrees. So our correct choice would be C. Fourth question, from a point P which is at a distance of 13 centimeters from the center O of a circle of radius 5 centimeters, the pair of tangents PQ and PR to the circle are drawn. Then the area of the quadrilateral PQOR is this. I will draw the figure first, so we'll understand what we are asked. Okay, so here is the circle, and then there is a point P somewhere here. Let's say there are tangents now. There are two tangents Q, and one is R over here. Okay. So there is a center over here. Okay, and we'll take that as O. We'll draw this. So that completes our quadrilateral, which are the vertices P, Q, O, R. Okay, and the line over here, and this line we are given as 13 centimeters OP. Now we are also given the radius, which is 5 centimeters. We are asked to find the area of this quadrilateral. To find the area of the quadrilateral, we'll have to find the area of these two triangles. Okay, now these two triangles are actually congruent to each other, which means if you find one area of one triangle, we as good as finding the area of the other triangle. Then we add the two triangles and we will get the area of the quadrilateral. Okay, now we know that this is the perpendicular here, both of these. Okay, and if these are perpendicular, that means this has got to be the hypotenuse. Okay, now, or you can say, in other words, over here, this will become the base. Okay, this will be the base and this will be the height because the perpendicular is here. The perpendicular formed is here. So if we want to find the base, we'll have to use Pythagoras theorem. We know this is 5, this is 13. We'll have to find this. Once we find this, we get the, then we use half into base into height formula. So let's begin. So directly try to take the Pythagoras theorem for in order to find either PQ or PR, with the same thing. We're going to take PQ. So PQ is equal to square root of, and directly and take 13 square minus 5. So that gives us PQ is equal to 169 minus 25, and that will be giving us 144, which means PQ square root of 144 is 12 centimeters. So our base is going to be 12 centimeters. Okay. Now, if you're wondering how this is the base, see, we are used to seeing this as our base. Okay, where this is the perpendicular, this is the height. Okay, same way, this is the height now, and this is the perpendicular. Something similar we get to see when proving basic proportionality theorem as well. Okay, so this is 12 centimeters. We got the height, we got the base, we know the height, and now we just need to apply it to find the sum of the either you can find out the area of one triangle and then double it up, meaning this plus this, or directly you can say 2 times the two triangles will give you the because you found out 12 centimeters over here. We know tangents have equal lengths of a circle. If this is 12 centimeters, and this has also got to be 12 centimeters. And this is common side, 13 centimeters. Radii also are the same. We usually how we prove by RHS that the two uh, triangles are congruent. We don't have to prove anything over here when they are congruent. We just need to use or apply that knowledge. Okay. So what is the formula? Formula is sorry, area of one triangle is equal to half into base into height. Okay. Now, if you want to know the area of quadrilateral PQOR, it is actually area of triangle 1 plus area of triangle 2. Okay. If we look at this, it is this plus this. Okay. This one. It is this plus this. So instead of both the triangles are the same, we can say 2 times. Okay. 2 times area of triangle. And how we find out the area of triangle? 2 into half into base into height. This 2 and 2 will cancel, and this we need to write base into height. And base is what? Base is 12, height is 5. So we get 60 square centimeter. And so correct answer would be A. Okay. We'll go to the next one, fifth one. At one end A of a diameter AB of a circle of radius 5 centimeters, tangent XAY is drawn to a circle, the length of the chord CD parallel to XY and at a distance of 8 centimeters from A. Okay, looks a little bit complicated. Let's first draw the figure and you will have an answer. I'm thinking rough figure. So this is our fifth question. So I'll draw a big one so you can understand better. Okay, here you go. This is first circle. We are told over here that x, y is a tangent. So somewhere over here like this. We'll take x, y, and it is meeting at A, and AB is the diameter over here. Okay, and we have CD as a chord which is parallel to this x, y. So we take that somewhere over here. That becomes C and D parallel to this. AB is given on them. We are told that distance of this tangent from this chord is 8 centimeters. So this would be 8 centimeters from here to here. Okay. Then we are also told that this is the center O and the radius is 5 centimeters. So this is 5 centimeters. Okay. From here, put it over here. 5 centimeters would be from here to till here. Okay, from here to here. That means this part will be 8 minus 5. So this will become 3 centimeters. And we can draw a radius from here to here. Now radius is 5 centimeters. Okay. I hope you can understand this. I'll just cancel this part. Don't worry about this part. Okay. This is the radius from here to here. Okay. And why I've drawn the radius, I'll show you. I've got this part as 3 centimeters. How did I get this as 3 centimeters? This full thing we are given as 8 centimeters. Okay. The radius is given as 5 centimeters. So from here to here is 5. From here to here is 8 centimeters. That means 8 minus 5 will give us this part, 3 centimeters. This is 3, this is 5, and this is got to be perpendicular. So then we can use a Pythagoras theorem to find out this. Okay. And if we find out this, we can find out this part as well, with perpendicular from the center by saying the chord. I'll show you how all this happens. Okay. And we will be able to find what is CD. We need to find the length of this chord. Okay. So let me write down first everything, and you can have a look at the um, diagram, okay, and see for yourself. Okay, I'll redraw the diagram if you want to over here. Over here itself, I'll redraw. Okay, that's the tangent. Sorry about that. Figure not very accurate. A, and here you have the diameter, see? And here you have the chord, which is CD. Okay, and the center will be here. Okay, and so dotted line will put. This is the radius. So this is 5 centimeters. This is 5 centimeters, and this whole thing from here to here is 8 centimeters. Okay, fine. And I'll also, this is O, mark this as E over here. Okay, now let's begin. Okay, so OA is equal to OB, which is the radius given to us as 5 centimeters. AE, which is this part from here to here, from the tangent to the chord, is given to us as 8 centimeters. Now, OE is equal to AE minus AO. So this is the part I was talking about. OE is nothing but AE minus AO. 8 minus 5. That gives us 3 centimeters. Okay. Next, OC is the radius of the circle. So hence 5 centimeters. Which is OC? OC is here. Then, okay, we say OA is perpendicular to XY, since XY is tangent to circle. Okay, so XY is here, okay, and it's tangent. So that's why OA is perpendicular to XY. Now we got that, and we are told that XY is perpendicular to CD. Okay, this is given to us. And therefore, we can say angle OED plus angle OAY is equal to 180 degrees, which is sum of interior angles. You can say a supplementary. Well, that means 180 degrees. Which other one? See, these two are parallel to each other. Okay, this one is parallel to this one. So we are saying that this angle plus this angle, the sum has to be 180 degrees. These are interior angles. Okay, so that's what we say. So OED we need to find out. So OED, but OEY we have told it is 90 degrees. So 90 degrees is equal to 180 degrees. That means angle OED equal to 90 degrees. Okay, and that means that OE is now perpendicular to CD. The OE is perpendicular to CD. So now that we have shown that this is perpendicular this, we can say also that the perpendicular bisects the chord into two equal parts. Okay, that is the next part that we are going to say. So we can say therefore that CE is equal to ED. Okay, because perpendicular from center bisects chord. Okay, done. We can mark this as 1. Then we can say in right triangle OEC that OC square is equal to OE square plus EC square, which is triangle OEC. The OEC is here. OEC. We are saying using a Pythagoras theorem here, since we now know this is perpendicular. Okay. Next. Okay. So we say we need to find out EC square. take EC square is equal to OC square minus OE square, and we can say EC is equal to square root of OC square minus OE square. EC we take the OC is 5. So 5 whole square minus OE is 3. So 3 whole square. EC is equal to 25 minus 9. EC is equal to square root of 16, and that is 4 centimeters. And then we can say CD is equal to CE plus ED. And that is 4 plus 4, which is equal to 8 centimeters. And so our correct choice is D. Okay. CD. So we found out here this was E. This one E. CE plus ED gives us CD. This is, if this is 4, this is also got to be 4. 4 plus 4 is 8. So D is the correct choice. Next one, question 6. In the figure, AT is the tangent, okay, to the circle with center O, which is here. OT is 4 centimeter, and angle OTA is 30 degrees. Then AT is what? Okay. Now the angle is given. The first thing that comes to our mind, our angle is using trigonometry ratio. So if we draw this from here to here, okay, this will become perpendicular, right? This is complementary angles over here. So that means we can use 30. We need to find out this part, AT, when this part is given. So we can use cos of 30. If you use cos of 30, then this side is involved and this side is involved. We can get the answer. Okay. So that's what I'm going to do. Let's take cos of 30 degrees is equal to 80 upon OT. Cos of 30 degrees, root 3 upon 2. 80 is what we need to find out. And OT is given to us as 4. 2 on the 2, 2 to the 4. This goes and cross multiplies over there. So we get 80 is equal to 2 root 3 centimeter. So our correct choice would be C, 2 root 3. Next one, in figure, this figure, if O is the center of the circle, PQ is a chord, and a tangent PR makes an angle 50 degrees with PQ. Okay, here an angle POQ is equal to what? So this is very easy. This is a tangent, but this full thing is 90 degrees. Okay, see, from here to here is 90 degrees, and from here to here is 50. So 90 minus 50 will give us this portion, that is OPQ. Let's do that. Take 7. Question. We have right over here. OP perpendicular to PR. Okay, in this sense, PR is tangent to circle. And so therefore angle OPR is equal to 90 degrees. Therefore angle OPQ is equal to angle OPR minus angle QPR, which means it is 90 degrees minus 50 degrees equal to 40 degrees. Okay. Now, further, now we have found out that this particular angle is 40 degrees. This side is equal to this side because they are radial. And if this side is equal to this side, that means this angle is equal to this angle. Okay, because angles opposite to equal sides. This is 40, this is 40, we can easily find out this. This will become 100. And that's what we need to find out. I'll write it down over here so that you can understand what I just said. Okay. OP is equal to OQ radii of same circle. Okay. Therefore, angle OPQ is equal to angle OQP. P. Angles opposite to equal side. Okay. Therefore, angle OQP is 40 degrees. Okay. Then in triangle OPQ, angle OPQ plus angle OQP plus angle POQ is equal to 180 degrees. Why? Sum of all angles of triangle. Then this is 40 degrees, this is 40 degrees, and POQ is what we need to find out. Equal to 180 degrees. 40 plus 40, 80, we take it on the other side, become negative. 180 minus 180 degrees minus 80 degrees is 100 degrees. So POQ is equal to 100 degrees. That is the answer. So our correct choice for here, we are doing 7. Okay? This one, correct choice would be A. Let's move to the 8th question. PA and PB are tangents to the circle. Okay. Center is O. Angle APB is 100 and APB is 50 degrees. And so not very clear, but we need to find out OAB. Okay. Well, then angle OAB is what? So OAB will be. Now, see, we've got this angle. This is a tangent. So that means this becomes 90 degrees. This becomes 90 degrees. Okay. And if we take this quadrilateral OAPB, okay, then 90 plus 90 is 180. 180 plus 50 is 230. Quadrilateral sum of all angles is 360. 360 minus 230 gives us 130 degrees. Okay. Now this is 130 degrees. Okay. And we know that this OA and OB are radius. So that means they are equal. And if these are equal, that means these two angles are also equal. Okay. Now sum of all angles of triangle is 180 degrees. This is 130 degrees. Okay. 180 minus 130 gives us 50. And these two angles, the sum of them will be equal to 150 degrees. That means individually how much it is. I'm just write it down, whatever I've said just now. Okay. So angle PAB equal to angle PBA equal to 90 degrees. Since PA and PB are tangents to circle. In quadrilateral PAOB, angle PAB plus angle PBA plus angle APB plus angle ABO equal to 360 degrees. Okay, and this is sum of all angles of triangle, of quadrilateral. Okay, well, this is 90 degrees, so 90 degrees plus 50 degrees plus angle ABO equal to 360 degrees. Okay, where for angle ABO is equal to 130 degrees. And we say OA is equal to OB, which is the radii of same circle. Okay. Let's say therefore angle BAO is equal to angle ABO. Angles opposite to equal sides. Angles opposite to equal sides. And in triangle AOB, angle BAO plus angle ABO plus angle AOB equal to 180 degrees. And this is sum of all angles of triangle. So 2 times the angle OAB. Why 2 times angle OAB is because BAO is equal to AB. So it's taken as same. Plus angle AOB. AOB is what was the AOB? AOB is 130 degree. So 130 degrees when you take on that it becomes negative. 180 minus 130 gives us 50 degrees. Yeah. Okay. Cancels, we get 25 degrees. So that means angle, therefore angle OAB is equal to 25 degrees. So correct answer choice is A over here. Next, if two tangents inclined at an angle of 60 degrees are drawn to a circle of radius 3 centimeters, then the length of each tangent is equal to what? Okay, so it's not a difficult question. This is what it means. If we draw a figure like this, okay, and particular, and also the center, also this is the point outside, external point, draw it further. So the radius is 4, 3, okay, and we are told this whole thing is 60 degrees. So this whole thing is 60 degrees, but then individually it is 30 degrees. Okay, 30 degrees. Again, you have to use trigonometric ratios over here. So we need to, this is your 90 degrees here. And we are asked to find out the length of each tangent for this one. Okay. So if this is the right angle, that means this line here, which connecting the center to the external point, becomes the hypotenuse. This is the hypotenuse. We are given this part. We are asked for this part. That means we can use 10 of 30 degrees in order to, because 10 of 30 degrees will involve this side and this side, not the hypotenuse. So we write over here 10, 30 degrees is equal to the 10 of 30 degrees, which is over here, is equal to the radius upon the tangent length. 10 of 30 degrees is 1 upon root 3. Radius is given to us as 3. And tangent length is what we need to find out. If we cross multiply with the tangent length equal to 3 root 3 so centimeters. Yeah, centimeter. 3 root 3 centimeter. Which means that our correct choice is D. That completes our 9th question. Okay. Now for the 10th question, in the figure, if PQR is a tangent to the circle whose center is O, AB is a chord parallel to BQR, okay, parallel to PR, and BQR is 70 degrees, then angle AQB is equal to AQB is equal to what? Okay. Now, this is a slightly longer answer. I doubt whether it will come for an MCQ. But anyway, I've solved this so that you know how to get it. Okay. So, the main thing is this is parallel to this thing. That means you see ABQ and BQR, they form this and this form alternative. So we get this as 70 degrees. And this full thing here is 90 degrees because this is perpendicular. So this minus the 70 degrees will give you that inside part, 20 degrees. The 70 plus 20 is 90 and 90 plus 90 is 180. So this has to be 90. This becomes perpendicular. So we give it some name, say M over here. And we say OM is perpendicular to AB. not something. We with bisecting AB, that means this is equal to this. We need to prove that these two triangles are congruent. If we prove these two triangles are congruent, we can say this angle is equal to this angle. And if we say these two angles are equal, then the addition of two angles will give us AQB. That's it. But yes, that is how the solving is. I'll show you a full solving. You, if you know how to do it, then you don't have to show the full solving. Just choose the right answer, or you may get it for 2 marks. So let's have a look at this. Question 10. This is the last one. Let's see how we do it. OQ perpendicular to PR. So PR is tangent to circle, and angle OQR equal to 90 degrees. Therefore, angle OQB is equal to angle OQR minus angle BQR. So OQR is 90 degrees and BQR is given to us 70 degrees. This gives us 20 degrees. Then we mark this as 1. And then with AB, we have been given parallel to PR. Okay. And therefore, we can say angle MBQ is equal to angle BQR. Okay. And why it is equal? Because alternate interior angles are equal. Okay. And therefore, we get angle MBQ equal to MBQ is equal to 70 degree. Okay, because BQR is 70 degree. Okay, so you can say in triangle MQB, we have angle MQB plus angle QBM plus angle BMQ equal to 180 degree. Say this is the sum of all angles of triangle. BQM is we found out BQ. Yes, and this is BQM. We found this as 20 degrees. Okay. We same as OQB, it's 20 degrees. QBM we got as a 70 degree, and BMQ is what we need to find out. And this is equal to 180 degree. 70 plus 20 is 90. 90 when it goes on the other side become negative. 180 minus 90 is 90. So angle BMQ equal to 90 degree. So we got BMQ equal to 90. That's why you can say QM is perpendicular to AB. Therefore, QM is perpendicular to AB. Okay, and then we straight away go to proving these two triangles now are congruent to each other. So we say for in triangle AQM and triangle BQM, AM is equal to DM, then QM is equal to QM, and we can say that angle AMQ is equal to angle BMQ equal to 90 degree. I'll show you. We said AM is equal to BM. The perpendicular from the center bisects the chord. We said that MQ is equal to MQ, common side, and one more, AMQ is equal to BMQ 90 degree, which we have already shown. Okay, so we say perpendicular from center bisects chord, common side And this is from it's shown over here. Can show here two we can write down here. Two. So from two, this one can be to anyone. So you can write over here as from two. You can say therefore triangle EQM is congruent to triangle BQM. And this would be by SAS. Okay. And therefore we can say how it is SAS. Show you side, angle, side. Okay. And now we can say that angle EQM is equal to angle BQM. Write angle EQM is equal to angle BQM, and we say this is CPCT, corresponding parts of congruent parts, corresponding parts of congruent triangle. And since BQM we found as 20 degrees, now we can see that we need to find out angle, AQB. So where is AQB, right? So we just write away we found out BQM, so we can therefore angle EQM equal to 20 degrees. And therefore you can say angle AQB is what we need to find out is equal to angle sum of angles EQM plus angle BQM. 20 degrees plus 20 degrees equal to 40 degrees, which means the correct answer is B, 40 degrees. Okay. So with this, we come to an end of this video. This video was done in a real hurry to get it out before your exam, which is tomorrow. All the best for your exams tomorrow. There were more requests, and I could not do justice to all of the requests that were there. But I thought this would be useful. Questions will be coming on this. Okay. So if you have the time, then go through this video. All the best. Share this if you have watched. Those who have watched this video and have liked this video, please hit the like button. Share this with your friends as well as your classmates. Please do subscribe. That only helps me in doing more videos. And I wish you all the best for your exams tomorrow, Maths Level 1 students. Okay, and do watch the sure short question video on for science as well. And the questions, I will be sharing them on the WhatsApp channel. The link for that is in the description box below. Thank you once again for watching this video, and wish you the very best in the upcoming examination. Thank you.